continuously remain in the memory state. It will hold its memory state. It will hold its value. Okay. Now, the clock pulse. Apply the clock pulse is equals to 1 and D is equals to 1. Alright. So, for the clock pulse is equals to 1 and the D is equals to 1, the output for the first NAND gate is equals to 0. And if that 0 is available at the third NAND gate, at the input of the third NAND gate, Q will be 1 and QR will be 0. As in, when the D is equals to 1, Q will be 1, but after some time at the instant of the clock pulse. That's why it will be in the set state as Q is equals to 1. And if the D is equals to 0, the output of the first NAND gate will be 1. Okay? And for the second NAND gate, my D will be over here. The 1 is there, clock is equals to 1. So the output of the second NAND gate is equals to 0. And Q bar will be 1. And that Q bar is going to be applied to the second input of the third NAND gate. So my output Q is equals to 0. Alright, because both 1, 1 is there. Alright, so Q is equals to 0, Q bar is equals to 1. So my flip flop will be in the reset state. Right? Now, the JK flip flop. What do you mean by JK flip flop? So the JK flip flop is the refinement of RS flip flop circuit in which it determines the state of RS type, which is defined in the JK state. J is used for set and K is used for reset. Okay, so it is also used for removing a not allowed state for the memory state. So what is a diagram? This is the diagram of a JK flip flop in which you are able to identify that over here this is the same as the clock RS flip flop. The only difference is Q bar is connected, cross couple connected with the J input and Q is cross couple connected to the input applied to the NAND gate 1 with the K. Okay, so the first NAND gate has 3 input, clock, J and Q bar. Second NAND gate has 3 inputs, clock, K and Q. Output of this corresponding NAND gates are applied to this cross couple connection of this NAND gate. Right. Now what is the difference over here? Which clock pulse that we are going to apply? Clock is having two types. It can be a level or it can be a edge. So which kind of my flip flop is activated in the clock pulse? If it is a level trigger, if my clock pulse is having either 0 value or the 1 value, it is a level trigger. If it is having a rising edge and the falling edge, it is an edge trigger. So over here my flip flop is an edge trigger. It means either on the rising edge or in the falling edge my flip flop is going to be activated. Right? Consider that my flip flop is a positive edge trigger. Positive edge means rising edge. A value of clock will change from 0 to 1. If clock is equals to 1, J and K both are 0, 0. Consider that J and K is equals to 0. And if my clock is equals to 1, then my output of the first and second NAND gate is 0 and 0. Alright, so Q and Q bar will be changed accordingly. Alright, apart from that, we know that if J and K both are is equals to 0, 0, my output will be of 1 and 2 NAND gate is 1, 1. Okay, so that 1 is going to be applied to the NAND gate 3rd and the 4th. So based on the previous state Q and Q bar, my output is going to be changed. But over here, it will hold its previous value Q and Q bar. That's why it is in the memory state. Even if the clock is equals to 0, it will act as a memory state. Okay? When J is equals to 1 and the K is equals to 0, when flip-flop Q is equals to 1, Q bar is equals to 0, it will be in the set state. And when J is equals to 0 and K is equals to 1, my flip-flop will be in the reset state. Alright? Now, the T flip-flop. See, the difference between JK and K is we are going to short J and K and make only a single input, that is T. T stands for toggle. That means by applying the input signal, if T is equals to 1, my output is going to be complemented or it is going to be toggle. Okay? At each edge of the clock. That's why it is useful for the binary counter, frequency divider and the general binary addition. Okay? So it is, as I have told you, can be made from the JK flip-flop. The T flip-flop has only single input T, two outputs Q and Q dash. So it can be constructed using the D flip-flop with the two outputs Q and Q bar fed back to each other. Okay? As over here we have used a NOR gate with the AND gate. So Q is connected to the first NAND gate, input of the first NAND gate, and Q dash is connected to the second input of the second NAND gate. Alright, this is a circuit diagram. If T is equals to 0, my output of both the AND gate is equals to 0, 0. And over here, NOR gate is there. We know that. If input at any of the NOR gate is equals to 1, output is equals to 0 for the NOR gate. Alright? So it will be in the memory state when T is equals to 0. But when T is equals to 1 and my clock pulse is equals to 1, the output of the AND gate is equals to 1. And over here, my value of Q will becomes 1. Earlier it was 0. Alright, because any of the input for the NOR gate is 1, my output Q is equals to 0. That's why when T is equals to 1, Q is equals to 0. T is equals to 0, Q is equals to will be in the memory state. Alright. Now what are latches? As I have told you, the latch is an example of bistable multivibrator. It is exactly having a two stable states. These states are high output and the low output. So a latch has a feedback path in which we can say that my information can be stored. So the latch can be a memory device that can store a single bit. Alright? So it is very similar to the flip-flop, but the latch are going to be activated based on the enable pin. Right? So what are different types of flip-flop that we have discussed? Flip-flops are like SR flip-flop, D flip-flop, T flip-flop, JK flip-flop. So latches are also having the same type, SR latch, gated SR latch and D latch. Okay. So what is SR latch? So the SR latch is an asynchronous device which works independently of the control signal. So latch is going to change its output depending on what is the present state of input. Okay? It won't change any output depending on the control signal. Consider that the SR latch can be created with the two NOR gates that have a cross feedback, cross coupled connection. Okay? This is the one, this is the second NOR gate. It's having a two outputs Q and the Q bar. So this SR latch can be formed with the help of NAND gate. But the inputs are going to be swapped. Okay? Over here, S will be there, R will be there for the NAND gate. formed with the help of NAND gate. What is gated SR latch? So gated SR latch means the simple extension of SR latch in which we are going to provide the enable pin. See, this is the structure of SR latch, cross couple connection of with the help of NOR gate, and before that I have placed the two NAND gate having the two inputs. One is up, another one is enable. So with the help of that enable pin, we can say that my latch is going to be activated. Alright, so that's why it's called a gated SR latch. Even though the control line is required, this SR latch is not synchronous because the input can, the output will change with the help of input only, not with the help of that control signal. Alright, if I want to form the D latch, the only difference is I am going to place the NOT gate over here. So the D latch is a transparent latch. It's a simple extension of gated SR latch, right? So this gated SR latch will allow us to latch the output without using S and R inputs. So we can remove one of the inputs, so only one input D is there, two outputs Q and Q dash. So we can remove the one input by driving both the send and receive input with the complementary driver, that is a NOT gate. Alright. If I am going to apply D is equals to 0, so any of the AND gate will receive 0 and another AND gate will receive 1. So over here we have done D latch, gated SR latch and the SR latch. There are different types of latch, and for the flip flop we have seen the SR flip flop, clock SR flip flop, then GK flip flop, D flip flop, and D flip flop. But still, if you have any doubt, you can ask me on my video ready. Till then, thank you for your attention.